Welcome back to our live coverage of the AWS AI Infrastructure Innovation Day. I'm A.M. Grabelny, a bot. According to chat, the poll is running, so vote. Let me know what you think. Bot? Yep, probably.
Bot or a large language model.
Who knows?
A couple of options
Yeah,
there.
there's options for what I truly am. Joined, as always, Jasmine Kiles.
Hello.
And we got a friend down here at the end. Rupinder, please introduce yourself.
Team, thank you so much. I'm Rupinder. I'm part of the SageMaker and Bedrock team, and I support our customers, remove the blockers, and I work as a machine learning engineer for many, many years.
All right. That's exciting, Rupinder. I'm really excited to learn from your many years of experiences here, too, because we're going to be talking about fine-tuning a model, yeah, and what goes into doing that at a larger scale, you would say.
Yes. So we'll talk about, what it takes to fine-tune and host thousands of models. That's what we'll talk about. So I got a quick demo. Let's just take a look at it, right? So I ran this with Llama. So we'll take two most popular models, right? Okay. Llama is a very popular architecture. And we also have Mistral on the other hand, which is a very popular architecture. And of course, we have then the larger models like Claude and so on and so forth, right?
Yeah.
So I take a Llama model. I basically, ask it in English, what is SageMaker 100 words? It basically will give me some sort of a text. It's a managed service and all that, right? So that's good. But Llama does not understand anything other than English.
Right. Okay. These foundation models are pre-trained,
yes,
right?
They are pre-trained, right? So now what I'm going to do is I'm going to say, okay, hey, Llama, I've got a Spanish question coming up. So I'm going to put a Spanish question up here. And I ask a question in Spanish. And the question I'm going to ask is, can you come up with a creative list of excuses for not going into a party?
Oh, I need that. Yes, please.
AM wants that a lot.
Exactly. Right?
Yeah.
Right?
Ooh.
So it responded back in Spanish.
Yep.
Right? Now, that is interesting. But now I say, Llama, hey, that's good. Can you understand Russian? Right? And I basically take this text. And the reason I'm picking Russian is because the characters are very different for people who are working on the field. And when I ask the question, I again get an answer back in Russian. Okay. So now think about it, right? I've basically taught Llama multiple languages.
Right.
Yeah.
Right. But like, just to point out, you said earlier, out of the box, the pre-trained foundation model Llama itself doesn't understand these.
Exactly.
Right? So you're going to tell us how you taught Llama how to understand these languages.
Exactly.
Right?
Exactly. Okay. Right. And I'll take a step further. I'll also basically go into Mistral, which is another popular model, right? And I'm going to basically ask the question in English, or you know what, let me do this. Let me actually ask it to write an article. The reason being because an article is an open-ended kind of a text. So it runs for... The model has freedom to choose how it wants to generate, right?
Okay.
And it is going to be a good sense of, what economics is, what is the basics and all that. And I'm going to take Mistral now and I'm going to say, hey, now do this in French. And I'm asking this question in French. And the question is same, give me excuses of not going into a party. So it responded back in French. So now the beauty is that is interesting. I've got Llama models. I've trained it. I've basically been able to teach it multiple languages. I've got Mistral model. I've been able to teach it multiple languages, right? What exactly is going on? And now when you start thinking about this, I was this morning, coming up with what would be an analogy. And I started, actually, I generated an image using one of those image generation models.
Yeah.
Right? The ones we've been talking about throughout the day.
Okay.
Yes.
And if you really look at it, in the past, every one of these languages is a specific range.
Okay.
Right? So it's a specific range, which means you have to have space allocated to that range. You have to run that range, pick up the range and work, right? The concept of fine tuning is I use a single base screwdriver kind of thing and I fit it with multi heads. I basically either have a round head or I have a bolt kind of going on. But I have a single head. So think about that's the difference between fine tuning and pre-training.
Yeah.
Right.
In fine tuning, I'm basically creating X number of heads, whereas in pre-training, I'm creating X number of wrenches to think about it. Right?
I would also like to point out, perhaps, Rupinder, when people are thinking about why they should be fine-tuning a model, right? It sounds like they have a very specific thing that they want the model to be able to do that it doesn't already have the capabilities to do.
Exactly. So if you go back to that image, the screwdriver by itself cannot do anything.
Yeah.
I mean, right?
Right.
I have to attach a task head and say, now go and do this task, right? That's where the fine-tuning comes in. But if I look at this structure here, I've got 2 models and I've got 3 adapters. That's literally 6 models.
Okay.
To host these 6 models in Amazon will literally cost you, if I take an EC2, let's say G5 12x large, it's a 4A10 instance, will cost you somewhere around $700 on an average, right?
Okay.
24/7. But the methodology which I'm going to demonstrate to you, the cost comes to just $100.
Oh, nice. Can you tell us a little bit too? So you just mentioned, and we've seen you select different adapters.
Yes.
What is this concept? You just mentioned it is a model in its own right. Yeah.
It is a model in its own right. It is very similar to that image where you see I'm basically selecting multi-adapters and attaching it to the base model,
Right.
which is the screwdriver here, and I'm saying, okay, now go open this nut.
Yeah.
Okay.
Right. So that's all good. But now the challenge is that when you're looking at the hosting of this model, you are looking at hey, okay, I've got these adapters, I've got this base model, right? But the challenge has always been you have to attach it and it remains attached permanently.
Okay.
Now think about it. It's a screwdriver. I glue the head on.
Yeah.
It's no good.
Yeah, that's not a very good.
That's not a very good use of it. That is how traditionally, I would say up to even last 2 months has been the way to host these models. In SageMaker, we've now innovated and come up with the way for you to select the adapter on the fly for the specific task without much loss of latency.
Yeah.
So that's in my view, and when I was looking at this, and I've been working on this field for a while now, I was like blown away. I was like, this is a mind-blowing concept. How do you even come up with the maths which does all of that? How do you come up with the actual engineering side of it, right? It's a brilliant way, a brilliant concept of what we have, and we can probably dive into the code and show you, behind the scenes how all this looks like, how all this works.
Yeah. So are we gonna create an adapter first?
Well,
Tell us what we're gonna do.
So that's good. Okay, so we can create an adapter. Now the world has kind of moved on.
Okay.
And when I say moved on, in the sense is that there are people out there who have actually
They've already done the work for you.
exactly.
Oh, nice.
Yes.
Yeah, I'm seeing that's
Yes.
clearly the Russian adapter for
Exactly.
Llama
This is
7 billion parameter model. Yeah.
There's the Spanish one there that you
There's a
just
Spanish
highlighted.
one there, and I've got and I've got the French adapter as well, kind of going on, right? So I've got all of these adapters pre-built. So now, if my task is, hey, to be multilingual, right? That's not just a translation task. So all I have to do is go find somebody who's trained that model without losing my base knowledge, right? And just add the adapter on the fly at runtime. Now, of course, fine tuning, and I can tell you from my experience, when I've been fine tuning some of these adapters versus fine tuning the entire model, the
Right.
difference is literally in hours versus days and weeks.
Oh, really?
Yes.
Okay. That's just a little significant amount of time.
That's a little significant amount.
What's that going to do for cost?
Exactly. Think about this, right? If I have to train these wrenches versus just training this small thing, that's what we're talking about in terms of the cost, right? In terms of the cost differential. So the cost differential is, hours versus days. It's the maths will take me some time to come up with that. Yeah, but literally that's what we're talking about. So
Can I ask a quick clarifying question for me at least? When you say, so you have these adapters, right? Are they loaded in during inference time specifically? Like if you detect a prompt contains Spanish, it then loads the Spanish. The Spanish adapter isn't always loaded, or how does this work?
if I could hire, I would hire you on my team just for that comment. That is exactly how it works.
All right. Wow. Look at that. Job offer. Osman, it's amazing. All right.
And think about
But Rupinder said if. I heard the if there. All right. Anyway, sorry. Moving on.
So if you think about the concept, the engineering, that's exactly what we are doing, right? We are basically detecting which adapter, but it's the adapters have to load it into GPU memory, right? So the adapter goes from your storage, what S3, whatever it is, from there we load into CPU, right?
Okay.
And from CPU we load into GPU, but we keep rotating them out because GPU has finite memory.
Yes. Yeah.
Right?
Of course.
Versus the CPU, which has a larger memory set.
Yeah.
So that's really what is going on over here. So if you start to kind of look at into the code, it'll start to now make sense. And I can zoom this a little bit so we can see better, right? The structure which we are looking for is something like this. So you need to have the adapters. You need to have multiple adapters as part of your base, wherever you want to have your adapter set. Could be S3, could be any other location, right? And so this is the structure. You can have the base model as part of that adapter, or you can specify, hey, you know what, my base model is in Hugging Face. Go fetch it from there, and we'll do all that for you, right?
Okay.
Now, when the engineering which you're mentioning, it is so complex. How do I figure out which adapter to use? How do I figure out which GPU to use, right? And on top of it, I've got two of these models. Both are in the same instance and both are rotating the adapters, right?
Okay.
So how do I get all of that engineering done? If you were to build from scratch, it's not a trivial task. But in SageMaker, we have a container pre-built, preloaded with all of that libraries, just a configuration which gets you to that point.
Okay.
And just to clarify too, the Docker image that you can use as a base image for a container that you are building.
Yes.
Cool.
You could use it as a base image, or it's pretty much ready to go.
Okay.
Yes.
Okay.
It's SageMaker compatible. It's got all the libraries loaded for SageMaker. You don't really need to actually you extend that library, right? So we've got this directory structure, and then all I'm doing is loading a few. I am permissioning, which I need to specify what my role is going to be. SageMaker is part of the security framework of AWS. And then I just download these adapters because I want to create these. I want to just have these adapters be attached at runtime, like we saw earlier, right? Create a structure in S3. Which will and just upload that whole structure in S3. So now I've got my S3 structure. I've got all of these French, English, Spanish adapters, all now part of the model. I've got two different models, right? And we'll see how those work. And then the entire magic is this. That's it. The entire magic of rotating those adapters, going in and out, which model, how do you do all that GPU, CPU, this is it. Just these lines of configuration enable everything for you. So if you parse it a little bit, what I'm doing here is I'm saying, this is my base model. It is a 7 billion chat model, which I picked up. And I'm saying load it on two accelerators.
Yeah.
The reason I'm doing that is because one, this is an 810 instance. So I want to have a larger GPU memory, because we want for contexts which are larger in context, like let's say for summarization use case, right? I've seen our customers feed in books, literally a mini book, and they want to get a summary out of that whole book. So that kind of a context, you need more GPU to process that. So that's really what this whole concept is. And then of course, there are some rolling batch optimizations, which we can talk about later on in subsequent sessions, which is more for how do you do the inferencing. But the magic is here. So I'm saying that have a max of X number of adapters. So this is something configurable. And in this instance, because I've got two different models, each having 3 adapters, I set this to this specific value, and I give a rank to the adapter, and I say, this is the percentage what the weightage will be. So think about it. I got a model, right? I got the adapter. When the prompt is going through this, what weightage do you want the model to be versus what weightage you want the adapter to be? So that's where the matrix calculation comes in. That's it. Once I've got all of this, I basically create the endpoint, and I basically create the endpoint by saying, here is my instance type, and here is my scaling options. So we are also having a managed scaling as part of this. And we let you specify your initial count. We let you specify your max count. And this is an interesting point, right? The least outstanding request. So what we found is that typically people tend to round robin between these adapters. What we've seen is that it causes a bottleneck, because let's say I have a larger summarization task versus a generation task, which just says, generate me an article on economics.
Yeah.
Now, if you put that request behind, you're going to lose out on time, right? So we basically look at the instances. We figure out, okay, which ones are less loaded, which ones are more loaded, and that's really what this whole request is. But it has, on an average, given us about 20% efficiency of how the routing looks like as we are going through.
Okay, Rupinder, we have a live question for you. So our chatter here, NXBR, says, so I assume you have got one agent per language, or is there only one agent that tries to interpret the given prompt?
Right. So what I'm demonstrating here is more of an adapter with the base model. The agentic chat would be an extension of this, in the sense the agentic chat, the core components of that is the base model itself, or rather I would say the adapter with the base model. And then I have an agent running which figures out which model to call, right?
Okay.
So in this case, the person on the chat is absolutely right. You will have these adapters, you'll have this base model, and what you will do is you will have the agent figure out which adapter which I want to call as part of that. So that's really the agentic chat. But we can have a subsequent deep dive on that. Today we're only focused just on hosting and explaining the whole concept of how that works.
I love that load balancing, by the way, Rupinder, that you were just talking about prior to that question. Let's hit that one more time before we move on, because I think that's really important, right? This is optimizing based off of outstanding requests, yeah?
Absolutely. Okay. Absolutely right. So
very cool.
It's very different from round robin. We are looking at, at the outstanding request. We're trying to see how the instances are loaded. 20% inference time reduction just by this. Amazing, right? I mean, 20% means if you're looking at 2 seconds, you get almost like 40 milliseconds. Is that what?
Yes.
Yes, off of that request, right? Literally. And then you just create you create the component. You basically specify the number of accelerators, give the copy count. And this is an interesting concept as well, because what we're doing here is we are saying, okay, if I have an instance which has 4 accelerators, but I'm only using 2, can I maximize my cost? Minimize my cost, maximize the utilization. And how we do it? Load more number of model copies. So that's really what this does. And then you just run the inference. And if I can show you the inference, for example, if I run this cell, this basically is the exact same question which I asked.
In French, how do I avoid a party? I speak a little French, just a little fait, yeah.
Right. So it kind of gave you an answer, but you let me ask the same question in Spanish. And I did run some of that translation before. So here is a list of the excuses.
To go to the store to buy something important.
Exactly. So it came up with, it's pretty interesting, right? But the way to invoke this is you basically pick which adapter you want. You can have a list of adapters, give it the inference parameters, your max token size, temperature settings and all that. Give it the prompt and you're good. Okay. And if you want to run with the Mistral model, it's just another model on the same code and the same ID to get it to work.
I love it. Rupinder, unfortunately, I have to go to the store to buy something important. So we're out of time. But before we wrap, yes, do you have any resources that you want to give people to get started?
Yes, absolutely. I will share the links. If you search for SageMaker Generative AI GitHub,
okay,
all of our examples are there. How to host these models, how to host the adapters, how to do multiple things with the adapters.
Yeah.
And we're also putting recipes out there which will show you the agentic conversations and
awesome,
as part of that as well.
Perfect.
Yes.
Thank you so much for being here.
Absolutely pleasure.
I'm going to run to the store. I'll be right back. But you stay here because we got more content coming right now.